This conference will now be recorded.
Right, so today we will be talking about something called as machine learning. Right, so people are like everywhere, this is the happening word. So they say like, okay, machine learning, artificial intelligence, all that things. So today is just like a basic session, so we'll not be dealing with some code. So today you'll get a basic understanding about what is machine learning, what are the major components, and also how do you deal with that analytics data science cycle. So what exactly is a typical cycle, and all those things we will be discussing. So what is the languages that we use, all of that we will be talking. So before that, I want to understand, what do you understand by machine learning? Right, so any guess?
Basically, my understanding is based on historical data, we are predicting some algorithm and make a machine understand that you whenever you see this kind of data, you can use this algorithm and give us a predictable analysis where predictable analysis and do accordingly.
Okay, good. So basically, very good answer. You said like you're doing some prediction based on the, what do you say, data that you're having. But machine learning is something where you are writing an algorithm to do something on a data, right? So this is a little bit broader term that we are using. So whenever you see, there are some other terms also that you need to understand. So along with machine learning, you see something called as data science. You also have something called as data analytics. You also have something called as, let's say for example, statistical modeling, right? Then you will also have something called as a business intelligence. So all these terms are like somewhere related, right? So you can't give a clear distinction between machine learning, data science, data analytics, statistical modeling, and business intelligence. But what happens is, you also have, okay, I'll also add one more term, as you can say, I also have something called as deep learning, right? So what exactly are these terms, right? So all of them seem to be interconnected. If someone says, okay, what is data analytics, the answer is same. You have a data, take some data, do some analysis, and try to predict something. Okay, fine. So what is data science then? Data science is also the same thing. You take some data, do prediction, do an analysis. Then what is machine learning? Machine learning is also same. I mean, usually people have a perception that all of them are same names, right? So deep learning means you take the same kind of data and then you do some algorithms and all that, right? So, but if you see what exactly you're trying to do is, this is the bigger domain, which means data science is a bigger domain where you are using all other things, right? So I will tell you where exactly it starts, right? So this is main important thing that you need to know. So today's session we will be discussing only this one. So we'll not go into any code, nothing. So today will be the basic understanding what exactly you mean by machine learning, right? So whenever you look at machine learning, everything starts with a problem statement that is there in your company or in the industry. So whenever you have a problem statement, so you have a particular data that is associated with some problem statement. Let us say you are talking to an e-commerce person. So he says sales are not going well. So there will be some data which is associated to every problem statement, right? So this is where everything starts. It could be your data analysis, it could be your machine learning, it could be your data science, whatever it is. So I will tell you what exactly is everything here and then where everything comes into picture. Everything starts with a problem. So your main thing is converting this problem into a solution. What is the solution for this problem? My problem is I need to increase some sales. I don't know how am I going to do it. So this is the data that is there. So how can I go ahead and then increase the sales is my problem statement. Now, once you have this problem statement, I have an associated data. First, what you're supposed to do is you're supposed to convert this particular data into a machine understandable format, right? So, what do you mean by a machine understandable format? Whenever I say data, you can have multiple types of data, right? So you can have structured data, which is your transaction details, right? So typically you will have like an Excel sheet, name, age, amount. So there will be no problem with that. So structured data you have. You can also have something called as a semi-structured data. So what do you mean by semi-structured data? Like your logs will be there, so website logs, Twitter data, so some kind of data which is not completely structured. There will be some information, but there will not be a structure in the data. You can also get something like unstructured data. So what is this unstructured data? Unstructured data could be your images, videos, right? Voice, sensor signals. So many things will be there which are unstructured. So all these things you should convert into something called as a machine understandable format. So whenever you want to convert it into a machine understandable format, you do something called as data cleaning or data wrangling. So this particular process, whatever you follow to convert this thing into a machine understandable format, so this is something called as your cleaning. So you do cleaning of the data. So you
So
clean the data.
basically, my understanding till now is like first we are having some random data, and on top of that, I am making it machine understandable, and the types of data can be structured, semi-structured, and unstructured.
Correct. So basically, whatever data you get based on your problem, you need to
Huh.
clean the data and convert it into a machine understandable format. Typically, so around 75% to 95% of your time is gone in cleaning the data. So this is where your major amount of time goes in this. 75% to 95% of your complete time for machine learning goes in cleaning the data, right? So this is step number 2. So how are you going to do it? If you get a very good structured data, then you're lucky. So there is no much thing to do. So just put something and then you get it. If you get semi-structured or unstructured, then you're having a problem because you need to convert it into a machine understandable format. Once you do a machine understandable format, you do something called as a feature engineering. What is feature engineering? So feature engineering is nothing but you are going to transform your data, which means you are going to create new variables, right? So you are going to create new variables, and also you will do some transformations for which you will be needing a business knowledge. Let us say, for example, a very simple example is you have a height and weight of people, right? So when you have height and weight of people, you find out something called as a body mass index, BMI, which you can use it for your analysis. So based on your business knowledge, you will try to create new variables from existing variables for your analysis. So this is your feature engineering part, right? So once you
Now in
have,
feature engineering. Can you just repeat one more time? I'm not getting why you are
Feature
having new.
engineering means, what exactly is feature engineering means? You have some set of variables. Let us say you have, let us say, I'll give you one more example. You will have age, and also you will have some other variable, purchase pattern, something like that, right? So people within age of 25 to 35 are purchasing some particular product more, and then people below 25 and above 35 are not purchasing that particular product. So based on that business knowledge, what you will try to create is, you will try to come up with some kind of a score, or maybe some kind of a new variable, right? So what exactly that new variable will be? Let us say purchase score. You will try to give a score to that people. Or one more very simple example, what I can give you is the same body mass index. You have a height of a person, weight of a person, you're trying to come up with the body mass index. Then typically whenever you have some date or something, so you will try to extract the quarterly information, right? So something like that. From an existing variable, you are trying to go ahead, and then you're trying to get some new variables from existing variables, which will be useful for you in your analysis. So that is something called as feature engineering, right? So basically you're trying to get new variables from existing variables, which will be useful for you in your analysis. Getting an idea?
Yeah, getting.
Nice. So once you do some kind of feature engineering, what is the next thing that you will follow is, you can see, once you do some feature engineering based on particular problem, you will try to build a machine learning model, build a ML model. So whenever you build a machine learning model, what exactly you get here is, it could be a problem, whatever you told, no, you're not just forecasting things, it could be a regression problem, right? So whatever problem, based on the problem statement that you're having here, you can connect it with a regression. It could be a classification problem, right? So whatever you're trying to build could be a regression, it could be a classification, it could be a clustering problem, it could be, let's say for example, time series related forecasting problem, classification, clustering. So it could also be, let us say for example, uh, what else, it could be a regression, it could be a classification, clustering, time series. There are some other things, right? So let's say you have something like a survival analysis, or maybe credit scoring, NPA. So basically this is on a very high level. So these types of problems can be solved, right? So regression, classification, clustering, right? So these are the major problems, or probably machine learning models you will build. Inside this you will have different types of machine learning models, right? So these are the machine learning models you build. And then once you build these models, what you do is, you can also do some kind of reporting. So let's say for example, the results that you are getting, you need to showcase in a good format. So what is that good format? You can use something called as, let's say in reporting, you can use visualization, right? So to create dashboards and all, and then try to build it. So this is your reporting
Basically,
thing.
all the
Your voice is breaking. Can you repeat it?
there
No, your
are
voice is still
four
breaking.
machine
Still break. Can you type it in the chat window if you don't mind? I'm not able to hear you properly. The voice is fully breaking, so can you type it in the chat window? A lot of noise and disturbance. So okay, the question is, understanding is we need to learn 4 ML models to get uh, they are the 4 types of ML models. So in each and every class, you will have 2-3 machine learning models. So in regression, you have few types. Classification, you will have few types. Clustering, you have few types. In time series, it's a concept, right? So time series modeling itself is a concept in ML, right? So these are the things you can it's not, these are not the models, they are the types of problems. So you can solve regression problem, classification, clustering, and time series problems. Within these you will have some kind of models to build, right? So these are the class of problems that we have. So now where exactly these terms come in is what we are going to see. So if you can see here, what is data science? Data science will have a programming knowledge. Let's say you have, let's say, R or Python or SAS or Java, or there are other programming languages you can use for analysis. Plus, you need to have a stats knowledge, right? R programming plus stats, plus you need to understand how all these things work. This is your complete as a domain, right? When you talk about visualization, you have something called as Tableau. So now Tableau is purchased by Salesforce. You have something called as Power BI, which is a Microsoft product. So similarly, so these are all the things that you need to know. You need to know how to clean the data, you need to know how to do feature engineering, you need to know how to build model, you need to know how to visualize model, along with statistics and some programming language. Plus, it is good to have some knowledge of Excel plus SQL. So basically, this is typically a data science domain asks for, right? So this is basically a data science domain asks for. Now, what is data analytics in particular? So whenever you talk just about analytics, no, analytics has nothing to do with complete thing, right? So you just need to know a programming language, right? So you just need to know a programming language. You should know, let's say for example, little bit of data cleaning, right? So and then feature engineering, and then building a model. So these are the major things that you need to do analytics. So there's no need for you to do reporting, there's no need for you to, like, what do you say, do data storage and everything. So this is what your data analytics is all about. Now typically, what is this statistical modeling? Statistical modeling will be dealing with only these three things: statistically significance of these three things. How do I deal my data with statistical perspective? How do I build my models in stats? How do I create new variables in stats? So this is basically dealing with statistics only, so nothing else. Business intelligence is a part of your ML, which is talking only about reporting, so nothing else. So this is only about reporting. BI is nothing but reporting. So nothing apart from that. Then deep learning is an advanced form of machine learning where you will talk only about neural networks. So basically, your deep learning has to do only about neural network where you have something called as CNN, RNN, and some other things, right? So there are like only related to neural networks. So this is the main differentiation that I can give you with respect to this. Now our area of focus is nothing but machine learning. So whenever you talk about machine learning, so what we are trying to do is we will be dealing with how to deal with these types of problems. So we are not aggressively looking at doing data cleaning, feature engineering, and reporting. Our focus will be to look at how do I build machine learning problems and try to solve a problem and get a solution. So once you get a solution, reporting is not so difficult task. Anyone can do a reporting work. Are you getting a basic idea about it? About all these things, whatever we are trying to discuss?
So feature engineering is like what we are doing in Kafka and Spark. That is part of feature engineering.
No, whatever you are trying to do in Kafka and Spark, you are just handling a little larger scale of data. That's all. So
That
in
putting.
Spark streaming, you're doing a real-time streaming of the data. In Kafka also, you are creating, I think if I'm not wrong, from your ingestion layer, extraction layer, everything, no? Wherever you are building a data lake or data mart, whatever it is, from one position to one more location, how easily, how seamlessly I can transport my data. That is nothing but big data. You're trying to manage a data in a larger scale. You're not doing any type of analysis in that.
Yes, yes.
You're just trying to see how I can store that data, how I can extract the data more effectively when the scale of the data is very large. So that is what your big data does. Big data analytics is doing analytics on big data. Instead of using a normal data, what you are seeing here, the data that you saw here, no, this data can be a regular data. This can also
Hmm.
can be a big data. So typically the only difference, no analytical methodologies will change in big data also, just that the size will increase, the data size will increase, that's all other things will remain the same. Any questions are
Okay.
there till here?
And in case of deep learning, I think you said neural network and CNN, RNN. I understand, but business intelligence, I am not understanding. Like basically, means just to make report is the job of business intelligence.
Yes, just to create reports from the analyzed data is the job of business intelligence. That's all.
So we'll be doing all the machine learning stuff and putting the data in a database or data mart. From there, they will be creating a Tableau report and Power BI report. That's it.
Correct. 100% true. So the reporting can be done on a data where you have built a model, or they
Hmm.
can take a raw data and also they can just simply do a descriptive analysis. They can just tell what is there where. Example, you take a survey of people who have purchased the product. There is no machine learning doing, there is no analysis in that. They can simply take the data, tell how many male are there, how many female are there, which area is purchased, what product is purchased, what is your sale, what is your profit. So there is no machine learning. It is just a reporting task.
Last question is, as I am doing like Kafka, like engineer, data engineering side stuff, and if
Hmm.
I can pick up the machine learning, career wise, how stable, I mean in general I'm asking, it's not specifically, I know it depends, but career wise how stable it would be in future, means what would be my benefit
I mean, as
in
I
case of
can,
career.
yeah, probably. I mean, I think I have answered this question. Now also, I'll repeat the same thing. There is nothing like a stability that you can expect, not only in this, in anything. The key to have a stable career is keep upgrading yourself. If I'm not sure, so let's say 4 months or 5 months back, you did not know Kafka and all, correct?
Correct.
So you have upgraded yourself. So now you are in a good position, right? So same thing
Yes.
I'll tell you. In the next 2 years, Kafka will be gone.
Okay.
Kafka, big data, Spark, everything will be gone. So as long as you're upgrading yourself, there's nothing to
Hmm.
worry. Even if you ask
Okay.
me, right? So whenever machine learning started, whatever
Hmm.
things that were there that time, and then whatever
Hmm.
things that are there now, there's a lot of
Yes, yes.
change, right?
Okay.
So the key to survival is just upgrade your knowledge. That's all.
Okay.
Because technology will change, so demand for technology will always be there. People who know latest technology, people who are updated in technology, so they will have a demand. That's so if you depend on only one single technology, and then if you are trying to have a stable career, you may not be able to do it. The case will be like the what do you say, IBM, what do you call it as, mainframe computers. What happened to IBM mainframe computers? None of them are in use now, correct? So
Yes,
similar
big
situation
computer.
come. So it's just that you need to keep on upgrading yourself, keep on learning. That's it. That is it. Career wise,
But
as you said, at this point of time, demand is very good. Demand will increase also because data keeps on increasing, and the number of quality people in this domain are very less. So there's a lot of demand. And one more thing is, this is not a easy skill to pick up, just like a programming language. So if you want to pick up a programming language, all you need is like 10-15 days. But this is not so easy to pick up. So the number of people in this domain are also very, very limited. So it's like growing domain, and also people are less. The knowledge time to pick up this knowledge is also little high. So there's always a demand. So there's nothing to worry. So that is the thing. Hope that answers your question.
uh, as you said, like we have to keep on learning. In my case, I'm saying that once people become at the age of 40 plus, the learning curve goes down. It won't be shooting high. So that's what I'm thinking, like till how many years I'll be able to learn. But basic wise, as I know any, I know some language. It's easier for me to pick up any language. So my question is,
Not like
till
that.
how many years I'll be able to pick up, or
As long as you want to be in the industry, you need to keep learning. So that is the key. Why people drop is because after some point in time, people stop learning, so they get outdated. That's all. So there's nothing to worry. So don't worry on those lines. So as long as technology is there, there will be a good demand. So that is how it works. So any questions in this at this point of time?
I have understood.
Nice. So this is the flow that happens. So now what we will do is I will tell you a basic about uh, ML. So how exactly typically how we will deal with a particular machine learning data, or probably a ML thing. So whenever you are going to talk about ML, there is a typical. flow that you need to follow. So what is the typical flow that you need to follow is what we will be trying to understand, right? So very simple technique. So okay, let's go back and then let me just open this here, right? So let me just go ahead and then let me explain you a simple thing. So you can observe whenever you are trying to go ahead and then build a machine learning model, what is the flow that you need to do? So whenever you are going to build a machine learning model, you need to know a programming language, right? So you will use this programming language to build a model. So this is your language that you use to build a model. So first thing, what you have a data. So once you get a data, you clean it. Clean plus transform it. So what do you do in cleaning? So in cleaning, you will handle your NAs, you will handle your missing values, right? So, and then you will probably do some summary statistics, descriptive statistics, all of that. So you'll find the mean, median, mode, etc., etc., etc. You will know how a data is there. You will find, you will try to deal with your NAs, NANs, all of that, missing value treatments. Then you'll also deal with your outliers. So all these types of things, you clean your data and then you transform your data. This transformed data, what you will typically do is, you will split this into two things, which is your training data set and then your testing data set. So what is your training data set and what is your testing data set is, this data set, okay, people what they do is typically they say this should have 70% of your data, this should be 30% of your data. So there's no compulsory percent as such. So you can take a 60-40 split, you can take a 80-20 split, you can take a 75-25 split. Based on the problem you can split it whatever you like. So there is no fixed percentage in this. Why do I need a training and a testing data is, whenever I want to build a model, here you will build a model. So build a ML model. So it could be any one of the above models that you saw. It could be like this. You can see here, it could be a regression, classification, clustering, time series. Any model that you want, you can build it. Now, once you build a model, what happens? A same model, you will test it here. So whatever model you have built on your training data, so the same model, what you will do, you will test the ML model here. So whenever you want to build it, you can build it and you can test a ML model here. Now, once you build and test a model, you will do some kind of accuracy checks, right? So you'll have some kind of accuracy checks. Once you complete this actual accuracy checks, so there are different ways of checking the accuracy of your model. You will try to optimize your model, which means you will try to optimize, do a good thing, and then again go ahead and then test the model. So this thing keeps on repeating. So it's a repeating cycle. So once you get a pretty good model, you deploy your model. So you deploy your model. So these are the main things that you have: accuracy checks, optimization, deployment of model. So this thing goes into real time. Understanding it? So typically, whenever you have your data, you clean it, transform it, divide it into a training and a testing data set, build a model, then you do accuracy checks, optimize it, and deploy in real time.
Actually,
Getting the concept?
will you report it? I mean, will you repeat it once? Because I missed from NA and NA and all this stuff. I am not understanding.
Okay, so I'll give you a small repetition. See what happens in the beginning, you will have a data. So everything starts
Correct.
with the data. First thing that you need to do is you need to clean the data first. Once you clean the data, what exactly happens is your data, whatever you are having, you will be transforming your data where you have where you have NAN, all the things you will transform them. So basically you need not have NAS and NANs in the data. So missing values, outlier, all of that you will treat. So there are different methods to do that. So you will use them, clean your data. Once you clean that particular data, what you try to do is you will have a training data set and also a testing data set. So the cleaned data, you will divide it into two pieces, right? So typically 70/30, but there is no fixed rule of that percentage. You can take as per the convenience. So once you divide the data into 70/30 or whatever it is, you will try to build a ML model. So how are you going to build a ML model? So select the model based on your problem statement, build the model first. Once you build the model, test the model on a testing data, right? So you build it, then you test it. Once you build, once you test it, you go and then check for the accuracy of that model. You need to check for accuracy, how well it is performing. So once you check for that accuracy, you need to optimize that particular model. Optimization means improving the performance of that model. Once you improve the performance of the model, you deploy that model in real time. So this is how a typical data science or probably a machine learning life cycle works. Is this clear? Any questions are there till here?
So my understanding is first we are getting the data, then on top
Hmm.
of that we are making filtration, whatever, cleaning operations and all this stuff, and then we
Hmm.
are transforming it. So
Correct.
what is so this NA and missing value or descriptive outlier, this is part of cleaning or part of transforming?
That is part of cleaning and transformation both.
Okay. So after that, once the cleaning and transformation belongs to this is descriptive and outliers
No, no, no.
miss.
Wait, I will give you a clarity about those things when we build a machine learning model. Don't worry on that.
Mhm.
Just
Okay,
remember
okay,
that is a stage.
okay. That is okay, okay. So after
Since
that,
we
I
are
am
beginning now, so
uh,
since you are beginning now, don't go into depth so that you may land up in confusion. Just be
okay,
aware that whatever data you get, you need to do some cleaning, you need to do some transformation. What cleaning,
okay,
what transformation, we will discuss. So typically you deal
okay,
with missing values, NANs, do some descriptive statistics and do some outlier analysis is just a preliminary stage.
okay. So once it is done, then we are training data and testing data. There are two types of data. Training data is 70%, testing data 30%. So in training data, we are making a build machine learning model. We are
Correct.
making a build machine learning model.
Correct.
First, once we receive the machine learning model, then
Mhm.
I have testing data. I run testing data on top of that. Like
Correct.
in this scenario, what will happen, kind of. So
Correct.
so once the testing is done, then we do the accuracy check through testing or something.
No, accuracy check, there are some metrics. So those things also we will see. There are some
Okay.
6, 7 types of accuracy checks you can do. So those things also we will see.
So after accuracy check, we optimize the data. How we optimize the data, I don't know.
We
Then
optimize the model. That is also a different techniques.
okay. So then
So
I am doing, so after building the model, you go for a accuracy check and then you try to optimize it,
then test
then
it.
test it, and once testing is done, then we deploy it and real time it goes.
Correct. So you do a building of the model, testing of the model, check the accuracy. If accuracy is not good, you optimize the model, again test. If it is not good, again optimize, again test. So as long as you're getting a good accurate model, keep on checking the accuracy, keep on optimizing it. Once you get a fairly good model, then you deploy it in real time.
Okay.
Getting this, no?
Yes, yes.
Nice. So what we will do is, so this is just a plain theory that we discuss today. So what we will be doing is, from the further sessions, we will be looking at each and every type of problem. So you will take a regression problem, you will take a classification, you will take a clustering, and also you will take a time series. So these kinds of problems we will take, and then I will show you how exactly this particular flow you follow, and then try to build a model, right? So those things we will go ahead, and then we will start from our upcoming session, right? So any questions in today's session that we are having?
No, more or less, you just share me this screenshot. I mean, for my
Yeah,
understanding.